All right, welcome everybody. Let's do this. Lesson number 3, dividing polynomials. This is the first page here. What I want you to do is complete the following. You could do this. This first page is not too bad by yourself. What I want you to do is try and do it by yourself, and then we'll go over it together, okay? So let's say you paused the video, you did it by yourself, and now you want to do it together with me. So, okay, let me fix the camera angle. Let me fix the focus. All right, so let's do the first one. So it just simply says what is 12 times 16, right? What is 12 times 16? This should be 192, okay? What about for the next one? Oh, this one should say 16 times 12, but okay, so that doesn't make a difference. That's still 192. What about the next one? 192 divided by 12. Well, we already know 12 times 16 is 192. So if I do 192 divided by that 12, it has to be this 16. And the same idea over here. What's 192 divided by 16? That has to be 12. Just something for us to look at. If I know that, let's say, triangle times circle is rectangle, right? And I know this looks crazy at first. If I know triangle times circle is rectangle, what else has to be true is that if I do this rectangle divided by this triangle, it has to be circle. And if I do rectangle divided by circle, it has to be triangle, right? Like for example here, if I have 16 times 12, it's 192. If I take this 192 and divide it by the 12 or the 16, I'm going to get the other one back. So what over here, what is 192 divided by 12, that's also 16, and this is 12. The reason I put this here is for you to see that this is another way of saying to divide, right? Okay, so let's look at the next one over here. Here we have our famous multiplying the binomials, right? Here we could FOIL. So how would you FOIL over here? What do? You do x times this x is x squared, right? Then what's the next one? X times 6 is 6x, right? Then what's the next part? You have 2 times x is 2x. And the last part, 2 times 6 is 12. Okay? So now here we have x squared plus 6x plus 2x plus 12. These two we can combine, so we just have x squared plus 8x plus 12. Okay? And there we go. And let's look at the next part. Here, notice that it's just this in reverse, right? So before we had triangle times circle is rectangle, you also have circle times triangle is also rectangle, right? In multiplication, the order doesn't matter, right? We're just flipping it. So you should still get x squared plus 8x plus 12, okay? So far so good. And when we look at this part over here, let's take a look over here. If I know that if I have this x squared plus 8x plus 12 divided by this, well, we haven't learned any techniques on how to divide this yet, but if I know this is, let's say, rectangle, and I'm dividing it by this triangle, it has, like if this is triangle over here and this answer over here is rectangle, I know triangle times circle is rectangle, so I know that this divided by this has to be x plus 6, because I know x plus 2 times x plus 6 is this. So if I take this and divide it by one of these, it has to give me the other. And that's the same idea here, that this has to be x plus 2. Okay? All right, now let's take a look at the next page. So the idea for this lesson is, if I have this polynomial and I want to divide it by this polynomial, how do you do it? So let's take a look. Let's turn the page, right? Okie dokie. And that's not the part I wanted to show. Let me pause the video real quick. C should be right over here. It should be x squared plus 9x plus 20 divided by x plus 4. So what's the technique for, how would I know how to divide this? Because before, we knew how to do this because we solved for this before. But now we don't really have that. So is there a technique to do that, and there is, and that's what we call dividing polynomials. So what I want you to do is, if you have your notes and your lessons, what I want you to do is follow along with this, okay? So I'm going to follow the steps and write the steps out with you as we do this problem, okay? So let's take a look at the first part. Camera angle is okay. Let me write out the problem. So this problem over here, you could translate it like this. You could have x squared plus 9x plus 20 and x plus 4 over here. It's the same as, like, imagine if I said, how many times does 5 go into 20, right? How would I solve that? What would you do to say how many times does 5 go into 20? You say 20 divided by 5 is 4, right? Or you could say, like, the long division, like this. You could also say how many times does 5 go into 20? You could also do this. And that's what we're asking over here. We're saying how many x plus 4s go into this? And this is the setup that we're going to have, okay? So the first step we're going to do is we're going to say, and we're going to repeat this a lot. We're going to say how many times does x, and when we're talking about x, we're talking about this x over here. How many times does this x go into x squared? And when we're which x squared are we talking about? We're talking about this x squared. So how many times does x go into x squared? Well, it's the same idea over here. It says, how many times does 5 go into 20? Well, what do? What went on top? The 20 goes on top, and the 5 goes on the bottom. So what's 20 divided by 5? It's 4. And that's the same idea over here. What's the algebra when I ask you how many times does x go into x squared? Which one goes on top? The x squared goes on top, and the x goes on the bottom. And now we just have to solve this, okay? And I'll write it over here so it's a little bit bigger. If I have x squared over x, okay, that's a very bad camera angle. Let me see. If I have x squared over x, what is this equal to? This is equal to, notice that x squared is equal to x times x. And what's on the bottom? This is x. How many x's are you left with? Just x, okay? So this should be an x over here. Right? And what's another way of doing the algebra with this? You could also say that, let's see, if I have space, I'll do it over here. If I have x squared over x, right? What's another way of doing it? You notice that there's that invisible 1 over here. And if I had, for example, x to the 3 times x to the 4, that's x to the 7. Right? What am I doing? If I have x to the 3 times x to the 4, it's x to the 7. What am I doing with the exponents? I'm adding them. So what do you do with the exponents when you divide them? Right? This will be, what's x to the 7 divided by x to the 4? This is x to the 3. What am I doing with the exponents? I'm doing 7 minus 4. I'm subtracting them, which is 3. So then what am I doing here? This has to be x to the 2 minus 1. And what is 2 minus 1? It's just 1. Or it's just 1x, okay? So this is one way of showing how many times does x go into x squared, and this is also another way, okay? This is one way and that's another way. Both ways are good to understand. But let's go back to the original problem, right? So we first asked, how many times does this x go into this x squared, and it goes in x times? Now, the second move you're going to do is, you're going to take this x over here, right? This x over here, and you're going to multiply it to this x. It's the same idea as if I were to do, like, let's say if I say 20 divided by 5. What do? You say it's 4, right? But what do you do next? You do 4 times 5 is 20, right? And that's the same idea over here. You do x times x, and what is it? It's x squared. Right? Because you're doing x times x is x squared. Then what do? X times 4 is 4x. I'm doing x times 4 is 4x. And that's over here. Okay? And yeah, this technique, I like to call it the boomerang. Okay? The boomerang, the idea is this pattern, right? It looks like an inequality symbol. Watch, it just goes 1, 2, 3. 1, 2, 3. Okay? So now what's the next thing we're going to do here? So that was step 1 and 2, right? Step 3, we're going to say parentheses, parentheses, and subtract. Okay? Parentheses, parentheses, subtract. So just watch over here. I say parentheses, parentheses, subtract. Okay? And don't forget that, don't you remember back in the day when you were dividing, right? What's 5 divided by 20, right? I'm sorry, what's 20 divided by 5? What is it? You say it's 4, so 4 times 5 is 20. And what do? Don't you remember back you did a subtraction sign over here? But really what they should have showed you in 4th grade that there are parentheses over there. And that's the same idea we have over here. Okay, so parentheses, parentheses, subtract. Now, what do we want to do next is distribute the negative, right? So if I have over here this negative x squared plus 4x, what happens? You see this negative x, oh, let me fix the camera angle, my bad. There we go. Okay, you see if I have this negative x squared plus 4x, what happens when I distribute it? This should be negative x squared. And then don't forget that you see this negative goes to this and this negative goes to that. So it should be negative 4x. Okay? And that's what you're going to do over here. All you need to do for this is change this sign to negative. And then over here, we're going to change this one to also negative. Okay? And let's speed it up a little bit. So now that we have this, notice what are we going to do next? We're going to combine like terms. So combine like terms. Here, notice that this x squared minus this x squared, right? Because this positive x squared became negative. So if I have x squared minus x squared, this is 0. And what about this one? What's 9x minus 4x? That's 5x. So now we just write 9x minus 4x is 5x, okay? Or we could say that, yeah, this part cancels, okay? Then what do? Bring everything down. Okay, so what am I going to do? I'm going to bring this 20 down, and then rinse, repeat. What this basically means is do the steps from 1 to 6. We have to repeat from 1 to 6 from over here. So before, what did we say? We said, let's go over everything. The first thing we did was, how many times does x go into x squared, right? How many times does this x go into this x squared? It goes in x times. Then what did we do? We did the boomerang, right? We did x times x is x squared. X times 4 is 4x, okay? Then what did we do? Parentheses, parentheses, subtract, okay? Now we distributed that negative, right? We distributed the negative. So this is negative x squared, and that's negative 4x. Then we combined the like terms. So x squared minus x squared is 0. 9x minus 4x is 5x. And then we brought down the 20, okay? And so we just did steps 1 to 6. Now we have to repeat 1 to 6. Notice that if we're going to repeat 1 to 6, how do I do part 1? Part 1 was how many times does this x go into this x squared? Now I'm going to say, and I'll write it over here, right? It'll be how many, and let me just zoom in a little bit. So try and focus here. How many times does x, so we're going to say that this x over here go into 5x. And when I'm talking about 5x, I'm talking about this 5x, right? Okay? How many times does x go into this 5x, right? So now, the same idea over here, don't you remember that if I said how many times does 5 go into 20, what did you do? You did 20 divided by 5 is 4. Notice that the 20 goes on top, the 5 goes on the bottom. What did you do here? The x squared was on top, then the x was on the bottom. Like how many times does x go into x squared? And that was x times. So then what do you have to do over here for the algebra for this? How many times does x go into 5x over here? What goes on top? The 5x goes on top and the x goes on the bottom, and this is 5. Okay? So then now I put this 5 over here, and it's a positive, and 5 times, and then what do? We have to do the boomerang, right? 5 times x is 5x. 5 times 4 is 20. And then what do? Parentheses, parentheses, subtract. Okay? Then I distribute the negative, so this is negative 5x. This is negative 20. And here I have 5x minus 5x is 0, and this is also 0, and that's it. We have a remainder of 0. Okay? So that's how you divide the polynomials. Okay? And what does that mean? Because don't you remember over here in this problem that if I said x plus 2, right? If I said x squared plus 8x plus 12, right? When I looked at this problem over here, it was x plus 6. But what else has to be true? Like if I say what's 20 divided by 5, it's 4. What else has to be true? That 4 times 5 is 20. And what was true over here? That x plus 2 times x plus 6, it equaled what? It equaled this x squared plus 8x plus 12. So what has to be true over here for this problem? That if I have x plus 4 times this x plus 5, it has to give me this original x squared plus 9x plus 20, and that, let's see if it works. X times x is x squared. If x times 5 is 5x. 4 times x is 4x. And 4 times 5 is 20. And when I add these two in the middle, I get x squared plus 9x plus 20. And voila, we're done. What I'd like you to do is try and do these two problems over here, 2 and 3, by yourself. And then I'll check them in class. All right? I'll see you.